Hi, welcome to this lesson for my Information Technologies class. This is the Cambridge Nationals Level 1 and 2 qualification. So if you want to find the full specification for this course, search for J808 specification and you'll get the full course documentation. I just want to make it clear for all my students the makeup of this course. It's split in two. Not all of the topics we study are in the exam. Some are just purely coursework based things. So for example, you're unlikely to be asked too much detailed question on sort of on database style questions in the exam, and vice versa. You're not going to be asked too much about things like cyber security in the coursework. Both those things you can mention in one of those two places. You're not penalised for that. But basically, the exam focuses on these 4 learning objectives, and the coursework focuses on these 4 learning objectives. So we're going to start doing some work on learning objective 6. So the first point in learning objective 6 is selection and justification of the appropriate software tools and techniques to process data to meet the defined objectives in a given context. Or more simply, should I be using a spreadsheet or a database? So both spreadsheets and databases are used to store data. In general, spreadsheets are used for storing and processing numerical data, whereas a database is primarily used for information that includes a lot of non-numerical data, such as names, descriptions, those kind of things. Spreadsheets are then particularly useful for processing, analysing the data, and doing things with it like creating charts, whereas a database is primarily useful for making links between different groups of information or different records, which I'll demonstrate to you shortly. So for example, if I wanted to analyse the sales data from all the McDonald's restaurants in the UK, I'm more likely to use a spreadsheet to do that. But if I wanted to store all the McDonald's employees' records, for example their name, bank details, addresses, performance data or their qualifications, I'm more likely to store those things in a database. Both spreadsheets and databases are both storing data, but it's how they're storing them or the kinds of things they're storing and what you're going to do with that data, which defines the difference between which one you're going to use. We often use Excel for spreadsheets in school, but there's many other options. Excel is just the freely available one. If you search, go to this Wikipedia page, there's many different spreadsheets available, some free and open source, others proprietary software. So the most common one we use is Microsoft Excel, and that's purely just from traditionally it's one that people first think of, but there's many others that have lots of similar features. Okay, so likewise there are many different database software, but we commonly use Access in schools. Okay, so I'm going to demonstrate. The best way to understand the difference between spreadsheets and databases is to demonstrate to you the differences. Let's take some basic data in Excel. We've got British cities and their populations. So let's say I wanted to look at I wanted to make a bar chart of the 10 most populated cities in the UK. First thing I could do is sort the data by, I've got it in a table here. I can just press this sort feature here, smallest, so largest to smallest, select the top 10, there you go, top 10, and I go to insert, I want a bar chart for this, and super easy, you've almost instantly got a chart showing you some data for the population of the cities. Something I'm quite excited about, which I just realized you can do in Excel now, is they have a new type of chart called a tree map, which shows you as an area a comparison between the sizes of the cities. I think this is a great way of showing how big each city is in comparison to each other. We've got other types as well. They're not always appropriate for what you want to do. Well, a pie chart is appropriate. It's a bit like a tree chart, but it shows you again proportionally how big they are. Sometimes a chart isn't appropriate for what you want to do. So, for example, for this, cities, a line chart is not really appropriate because it implies that there's some connection from one city to another, from London to Birmingham. A line is not appropriate in this case. So don't always think that a chart is appropriate. Any chart will do. That's not necessarily the case. A line chart is usually used for time flowing from left to right in some way. So yeah, just another set of data here. If I had some sales data for the type of burgers I was selling in a restaurant, let's put it in the table. Let's do that first. I could easily just go select it all, insert, give me a recommended chart. It's recommending either a bar chart, pie chart, what they call a clustered bar chart, or I'm going to call that horizontal bar chart. I've never seen this one before, but they call that a funnel chart. All of those are appropriate. But there you go. So that's super easy in Excel. It's not so easy. You couldn't really do that in Access in any easy way at all. So this is one of the main benefits of Excel. Okay, next feature of spreadsheets we want to talk about is formatting. So formatting basically means how you want information to be displayed. So it can be something simple as just bolding, italics, the font type, the font size. All of those things count as formatting, but on a more complicated level, you could say, well, how do you want a number to be displayed? So if I've just typed in here 0.5, that's all I've typed in. Now, what does that mean? This could mean many things. It could mean a currency, so it could mean £0.50. It could mean a percentage. So we can use formatting to display it in a certain way. So you've got some formatting options up here. I'm going to use the right-click Format Cells to show more detail. So you could say, right, well, what if it's currency? So you could say, well, it's always display it as a pound sign with 2 decimal places, or you have the option of changing it to a different currency if that pound sign isn't suitable for you. So it knows that 0.5 is 0.50 pounds. But what if by 0.5 you didn't want it to be currency? What if you wanted it to be, let's say, a percentage? So you could change it into a percentage for you. You should know, hopefully from your understanding of maths, that 0.5 is obviously 5/10, which is, oops, that's formatting in action there. It's thought I wanted 5/5/10 to be a date, so the 5th of October, but that's not actually, it's done some auto formatting there. It's not what I wanted. 5/10, if I put an apostrophe in front of it, should leave it as that. Obviously, we don't really want to display a fraction like that. We should know that 0.5 is 5/10, which is 50%. So it's changed our 0.5 into 50% for us. And another formatting option you have is to reduce or increase the number of decimal places. So all of these things, super easy on a spreadsheet. Right, next up, formula and functions. Now there's way too many formulas and functions to go over in much detail today, but basically, if you want to do some kind of calculation on any data on a spreadsheet, it's very easy. So I've got the top 100 towns here in the UK. If I wanted to know how many people lived in those places in total, I could very easily create myself, I could use a function or create my own formula to do that. It would be insane to go this, add that. I mean, I would eventually get there, but it's not very sensible. I'm going to use a function, the sum function. So you write in sum, and then you select the entire range of things you want to add. So very easy in a spreadsheet to do that. Again, if I wanted to find the average number of people in the top 100 towns and cities, I could write in average and do similar very quickly, and reduce that, use some formatting to reduce the number there, so it's easier to compare. Put it in comma style so it's easier to compare with the one above. If I wanted to find, let's say, the minimum number of people and the maximum number of people, I could very easily do that using these functions. So in terms of comparing this to a database, it's much easier. So I'm just trying to see why that has got 100 I was just wondering why we've got such a small number here for our minimum, 133.35. Obviously someone's put in, there's an inputting error there for the displays new port, so for want of not knowing what that is, I'm just going to delete that from our selection. And likewise I could do a max if I wanted to. So in summary, there's many functions and formulas you can use in a spreadsheet to quickly do some analysis on your data. Right, next up is modeling. Spreadsheets are very good for modeling things. Modeling is basically you making a kind of prediction using mathematics about what you think is going to happen in a situation. So let's say I think that towns and cities are all going to grow by 3%. I want to model what that's going to look like. So let me just so if you are familiar with how to model population growth, this is very basic. This is not realistic at all, but it's just a quick demonstration. If I wanted to show any town growing by a certain population, by a certain percentage growth, I'd take the population, I'd multiply it by this growth factor. Now, because I want it to grow by 3%, I write in 1.03. So this would be for 1 year, and it was going to show me what the population would be in the following year. And I'm going to format this with a comma style so that I can more easily compare it. In fact, we've got some varying formatting going on in general here. So I'm going to click this one because I like this one. The font's different. This one's Roboto, and this one's Calibri. So I'm going to click that one, Format Painter. There we go, that's better. Okay, so that's a very simple model. The idea here is I just want to demonstrate to you that spreadsheets are very useful for doing this. But it does bring me on to my next point, which is absolute referencing. So absolute referencing is when you have some value in the spreadsheet that is never it may change, but you also always want to be looking for it in the same place. So for example, my growth factor might be 1.03. So here, let me just clear all these because I'll make it clear what I'm doing. So here, what I want, if I want to make Aberdeen's population grow by 3%, I can click population of Aberdeen and multiply it by this cell here, and that will show me population growth. Now it works great for Aberdeen, but when it's tried to fill down here, it's gone let's make this wider. It's gone completely off the boil for the rest of them. So it's saying in 1 year Brighton's population will have gone up to this, which I have no idea what that number even is. Why has it done that? The reason is we didn't use absolute referencing. So for Brighton, what it's trying to do is take Brighton's population and multiply it by Bournemouth's population, which is also, again, completely unrealistic because we didn't use absolute referencing. So what do I mean by that? Basically, when this formula is correct, you want it to times the population of Aberdeen by 1.03, and when you get to Barnsley, you also want to multiply it by what's in this cell here, C1. But it's not doing that; it's multiplying it by what's in C2, which is nothing, column header. And then when you get to Basildon, you want it to times it by C1, but it's not. It's times it by C3 because what Excel does is when you drag a formula down, is it inferences that you're going to want the next cell. You're going to be wanting to reference the next cell down. So that's sort of not what we want to do. We want to make an absolute reference. That means we always want it to look at C1. So we're going to click, when we wrote this formula here, we should have clicked on C1 and pressed F4, give it those dollar signs, and that means it's an absolute reference, and that fixes the problem. Then everything is increased by just 3%. Now, I can now change this value if I want to adapt my model, let's say to 5%, and that works perfectly. So that's the idea of absolute referencing. It's basically saying, it's a way of saying, make sure you always look in the correct place. That place is not changing. Even though we're scrolling down, it's not changing. It's always C1. You can see there, it's always C1. Final thing I want to talk about using Excel is searching and sorting. Very simple to do. when you have things in a table in Excel, you can just click this down arrow here, and you can either sort them from largest to smallest or smallest to largest, or you can search for some specific value if you want, or put in a number filter. You can say you want everything between, let's say, 100,000 and 150,000, and it will just give you those figures. So that's very easy to do in Excel. So now I'm going to demonstrate look at the kind of thing you'd use a database for. Imagine I ran a set of stores and I had some employees and I wanted to store all the employees' details, what pay grade they were on and what store they worked in. Now, things like pay grades, the details of the pay grades could change for all employees. So I don't want to store things like pay grades specifically on each employee's records. They also the details of the store may change and who's working them. So I don't necessarily want to store those specifically on the store record. So we're going to have what's called a relational database. So we're going to create what's called a relational database, which means there's going to be relationships between records. This is something that Excel can't really do. Excel's good at storing data in a very basic way, and it's very powerful. But if you want to create links between different records and different sets of data, it's not really well suited for that. So a proper database where you can make a relational database, or relationships between records, is what you need. So I'm going to demonstrate some of those skills. Okay, so starting from scratch, I'm going to create a table for my employee records, for my employee details. Each employee is going to have their own ID number. So ID, so I'm going to say employee, Now surname.
Each employee will be a short text. The first name will be short text. You'll also store things like their telephone number, their address, their national insurance number.
So I'm going to create a new field here called Easy Ident, which is basically going to be an easy way for me to collect all this data together, which will make sense later. And I'm going to do something called a calculated field, which basically means you're doing some kind of calculation, whether it's a numerical calculation, or in this case I'm going to concatenate some data. So I'm going to put their first name, the and symbol, or the ampersand. I'm going to put in speech marks and a space, close speech marks, another ampersand. I'm going to put in their surname, and I'm going to put in their employee ID number. Press OK. Now let's see what that actually does. So I'm going to make up some random employees. So I've made some employees, and I've got this easy ident here, which means I can see their first name, surname, and which employee number they are all in one place quite easily, which is going to be useful later. Now, obviously, I'm going to be paying my employees, but I'm not going to store how much I'm going to be paying them on here. Let's say I had thousands and thousands of employees, and I want them all to follow the same pay structure. So I'm going to have a new table for how they're paid. So I'm going to go into Design View. So each pay grade is going to have an identifier. So I'm going to say pay grade ID. It's going to be a certain salary on each pay grade. So that's going to be a currency. And I'm also going to have a store discount so that employees can have a store discount. That's going to be a number. Okay, so when you set their store discount, set it to number, go to field size, go to double, and we want to display 2 decimal places, so set that to 2 if it's not already set. Right, so our first pay grade is £8,000. Get rid of this, I made a mistake there. Is £8,000 and they get a 5% store discount. Our next one could be 11. Discount. So those are my pay grade set up. So pay grade 4, you get £16,000 and a 10% store discount.
Next, I have details about my stores. So I want that on a separate table as well. So I'm going to create a table. Go to design view. For each store, we want to have a store ID. It can be an auto number. Create it for us. We might want to know the address of the store, the telephone number, and the manager.
Now, telephone number, I'm actually going to store it as a short text because you may have experienced this before, that if you type in any number starting with a 0, if you put it as a number, it then loses that 0 because we don't start numbers with zeros. So we tend to keep telephone numbers as short text. I've got a really obvious thing there, town or city that the store is in. Okay, so I'm going to be a bit lazy here. I'm not going to put too much details in. Okay, so we've got all our basic information spread out across different tables, and we're now going to want to create further tables to make relationships between that data. So, for example, if I wanted to have a table, I'm going to want a table that stores employee details, that links employees with how much they get paid. So I'm going to create a table. Close these actually. Let's close everything first. And create a new table called pay records. Okay, so what I want to do is to link together the employee with how much they get paid. So I'm going to write in this record, I'm going to have the employee number, and I'm going to also have their pay grade. Now, to make relationships, the easiest way for us to do it, if we know how our table is going to be structured, is to use the lookup wizard. So the employee number, we never want to write in any details. Once we've written them in once, we should never have to write them in again. So go to lookup wizard. We want to look for our information in a table we already have. So press next. We want to look for our employee information in the employee details table. So press next. Now, what we want to be able to see when we're trying to make these records is the employee ID and the easy identifier, so that I can easily see which employees is associated with which ID. Don't worry about this page. So I always like to unhide the key so I can just have that reference there, but we do kind of have it already here, but hide or unhide in this case doesn't make a huge amount of difference. And what are we actually looking to store? Even though it's quite complicated, we actually want to store the employee ID number, which is how databases work. They don't work in the same way human brain works. They just link one number to another number and see what happens. Well, not see what happens, but that's how they work. They link a number to a number in one table to a number in another table. And we want to enable data integrity there. Finish. Okay, and we want to do the same for pay grades. We want to say, right, this employee number is getting which pay grade number. So this, we're going to go to lookup wizard. We want to look in the pay grade details. We want to take the pay grade ID, and we'll take the salary as well, so we can see in a minute which salary we're selecting. There we go. And we actually want to store the pay grade ID. Okay, so what does that actually do? Well, let's press pay records here, and we're going to create a form, just an auto form there. Okay, and then go to view, form view, and this will now allow us to select one of our employees, so let's say John Carter, and now we can see John Carter is employee number 3, John Carter 3, click it. It only displays his number there, which we can find a way around in a moment. And what pay is he going to get? It's just starting, so let's give him £8,000. Okay, so that's good. Press next record. Let's say I then got Fred Carpenter, and he's going to get £15,000. Good. Right, if I close that, it'll ask me to save it, and it's my pay records form. If I go back to if I go on the pay records table, it will store that information there. The employee 3 is getting pay grade 1. Now, at the moment, that doesn't look particularly helpful to anybody, but we can show how that's useful shortly. Just as a side note, if you actually, when you've selected something, it's going to show the first option. So 3, when I selected it, it's showing 3. It's not showing his name. You can get around that. If you go into Design View, click on the one you're interested in, go over to Format, and set. So it's saying it's showing 2 columns. Column widths are this and this. If we set this first column to 0, and when I go back in to Form View, it will show me his name, but it will still, if I make a new record, let's say Usman Ahmed, 16,000. If I close that, go to, sorry, yeah, I had an issue there with not having shut down one of my tables. It's a common issue with Access, is if you don't shut down things, it doesn't show them straight away, or it may not even save them at all. So Usman Ahmed, number 2, is on pay grade 4. If I go back to this pay records table, it is there, 2, 4. And we're not going to actually worry about the stores in this detail because it's a little bit more information we want to go into today. But how is this useful to us? Because at the moment, this table, sorry, not this one, this table it's not very informative. It doesn't tell us anything we particularly want to know. So we're going to create what's called a query. So query design. And basically we want to, in this particular query, we're interested in the employees, pay details, and how they're linked. Let's move this one over here. Kind of gives a visual representation of what's happening. The pay records links to the employee and the pay grade. So the pay record links to the employee and the pay grade details. So what we can say is, can you show us all the employee details and what the pay grade details are? So can you see their pay grade details with a star? So it will show us employee details, pay grade details. They're not directly linked, but if we run this query, it shows us everything we need to know. So we can see John Carter, I should say, is getting £8,000 and his store discount is 5%. We've also got stuff, well these are blank because I didn't fill them in. You can leave stuff out if you don't want to. This isn't a lesson about queries, so I'm not going to go into too much detail. But that's just a kind of basic demonstration of the major differences between Excel and Access. Final thing I want to mention about databases is that they're very easy to do what's called validation, which means ensuring that data is put in a valid way. So you can do that by making sure, is the data the correct type? Is it within a certain range of values? Has the user actually entered some data, so a presence check or a length check? Show, is the data too long, if they use too many characters? So those are some basic forms of validation I'm going to show you. First of all, data type. So if I go in and let's say I'm trying to enter a new salary grade, so grade 5. Obviously this needs to be numbers, but if I start typing in a lot, then it's going to say you can't do that. That's not a type of currency. It's a type of it's a string. It's text, so you can't do that. It has to be numbers. So that's a basic sort of type check. So next, I might think, well, I don't want any of my employees to get more than a certain amount of money, and I want to make sure no one accidentally enters a salary over a certain value. So if I go into design view, go to salary, go down here to validation rule, I can say, can you make sure that the value is always less than or equal to 60,000, so that none of my employees are getting more than 60,000. And then when I go back to datasheet view, if I attempt to put in a new salary, so let's say I wanted to say someone's going to get 27,000, so I write in 27, but because I'm not being very careful, I've actually put in 200. I've actually put in 270,000. Try and press enter. It will say you can't, because you've gone over that rule. So it's a way of checking that people are actually putting in the correct values in a certain range. You can get more complicated on that. I'm not going to go into that in detail in this video, but that's the idea of a data range check, a validation check using a range of data. Presence check means ensuring that someone is they can't leave a record empty. I'll show you how to do that. So if I want to show a presence check, that means I can't leave things blank. They have to be filled in. So if I go to design view and say, right, you must make their, say, telephone number compulsory. So you click on it and you go down to required, you change it to yes. So it says here, because I've done some previous data previously, those won't follow this rule. So what it means by that is, I already created these without a telephone number, so it can't go back and force me to put those in for there. But if I start a new person here, and I try and leave that blank, it will say, no, you can't leave it blank. You've got to enter a telephone number. It must be entered. So it's a way of forcing the user to make sure that something is actually entered. It's called a presence check. So let's say we wanted to make sure people put in telephone numbers correctly, which means only numbers and of a set length. So it has to have, I believe it's 11. So let's say they always had to put in an 11-digit telephone number. We want to if we look down this list here, we wanted to only ever be allowed to put in numbers. So we want it to be a digit. So to be a digit, it has to be a 0. Okay, so we go back into Excel. So for telephone numbers, we can use input mask here, and we say it has to be 9 digits. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Sorry, 10, 11. I meant to say 11, not 9. So that is going to force it to be you to give 9 digits. The 0 means digits, and only digits allowed. So if I go back and go to my table view, so let's make a new record. Let's say, so I'm going to put in the telephone number 065. If I try and do that, it's not going to let me. It has to be the correct length. Okay, so that's an input mask. It's another form of data validation. It's a whole other lesson on that I'll do, but for now that's the basis of it. So finally, we just wanted to quickly look at the advantages and disadvantages of spreadsheets and databases. So advantages of spreadsheets: you can use formulas to do calculations and recalculate automatically. You can do what-if investigations, so that's basically modelling. Models can be carried out. Worksheets can be separated into different sets in a workbook. Data can be presented in a graph quite easily, just so you can spot trends and patterns more easily. Data types can be chosen to match the data being stored and processed. We didn't really go over that, but yeah, that's true. Columns and rows can be locked to maintain data integrity. Yes, that's true. So it stops users from changing things. Absolute and relative referencing can be included. Yeah, absolute is when you're sticking with a value. Relative is when you sort of drag down and it changes the formula changes the formula to make sure you're doing a correct calculation. I can do more detail in that on another lesson. Data can be formatted to meet the needs of the audience. Yes, so you can make the format bigger, make the fonts bigger, clearer, coloured to make it more appealing, lots of other things. Advantages of database. Lots of data in records can be stored. Data can be added or edited if changes are needed. I mean, that's true for most things, but it's certainly true here. Data can be filtered or queried to find relevant results. That's probably the most important, is the queries, and the relationships between the records is the most significant here. Data can be stored on a specific field. Yeah. A password can be used to maintain the security of the database. True. It can be used with other software, for example, send personalized letters. Yes, we didn't go over it, but you can create reports and letters. You can also import data from other files. Validation can be set. Yep, we did some of that. Reports can be generated. We didn't do that on this lesson, but it is true. Advantages of both. They can import into other documents. Sorry, it can be imported into other documents. Yes, that's true. It can be saved and backed up to prevent loss and damage. Fairly basic, but true. And can be shared electronically. Yes, also true. Disadvantages. If the model is created, the results may not be realistic. I personally don't see that as a disadvantage of a spreadsheet. That's just the user not knowing what they're doing, but they think that's a disadvantage, so it's worth bearing that in mind. Spreadsheets may take a long time to create. Again, I don't think that's a particularly strong argument. Inexperienced users may struggle with the functions and formula needed. Again, I don't think that's a particularly strong argument either, because if they're not qualified, they shouldn't really be using it. But an error in a formula can affect the results. Yeah, text cannot be manipulated easily. Yeah, that's fairly true. Yeah, knowledge and skill with for disadvantage of database, knowledge and skill with databases are needed to set one up. That's true. I mean, all of this could basically be summarized as saying users need to be trained fully. So if data is entered manually, errors can be introduced. True. So and then it's giving you some examples of how they might be used here. Okay, so today's actual written work I'd like you to do and then submit to me, and I'll give you details about how to submit. Is first of all do these very basic questions. With this 4-mark question here, explain why database is the most appropriate software to use for storing and processing customer data. Now, think really carefully about how you're going to get those 4 marks. 4 marks, basically, it's going to be 2 good sentences with a reason and justification, or some information, some basic knowledge followed by a justification. And then, secondly, so this is an exam question. This is the introduction to the exam question, which you can pause and read. And then, so you've got these 2 exam questions. Sorry, I said 3 exam questions. So these 2. So basically, think about this. For every 2 marks, it usually means point and explanation. Point and explanation. So it says 1, but you've got to do a point and make your explanation. And then here, explain 2 reasons. So you need 2 different things, separate into 3 marks each. So you're going to need a little bit more explanation for each one of those.